Hi, welcome back to Math 520 and welcome to week 11 of the semester. We're rapidly approaching now the end of the semester, and I feel like the topics we've been looking at here on inner product spaces has been a little bit abstract and a little bit challenging. So I think we're going to slow down here at the end as we get to the most important theorem we're going to see this semester. Right, in some sense, what we're doing this semester is we've been really focused on getting to the spectral theorem. And the spectral theorem is presented in Axler in section 7b. So what we're going to do is we're going to spend this week looking at section 7a and really internalizing the definitions and understanding what's going on. And then next week, we're going to look at the spectral theorem, which is section 7b. And, well, maybe, 7b is a difficult section, so instead of having all of that material next week, I'm going to try to steal some of its material and put it in this week. But the main focus of this week is going to be section 7a. And I'll also give some references to Trail's linear algebra done wrong so you can get a complementary point of view on it. But the upshot is that we are going to understand under what circumstance we can diagonalize a matrix on an inner product space where the matrix itself, or the linear operator itself, satisfies some kind of condition that respects the inner product, and we'll talk about the various ways that a linear operator can see the inner product structure, and that'll be part of what we do this week. And then next week, we're going to see how that forces diagonalizability, where you can find an orthonormal basis of eigenvectors. So we're going to bring these ideas together. Remember, we talked about eigenvectors and eigenvalues a couple weeks ago, and last week we talked about inner product spaces. So this week we're going to start putting those two things together, and then next week we're going to do see what the consequences are of having these this relationship between linear operators and inner product spaces. There are many beautiful topics that are in Axler that we won't have time to talk about. So if you take a look, the book is about, I think we will have only covered maybe about 60% of the book, maybe 2/3. So there are a lot of other interesting, beautiful topics in linear algebra. I encourage you to take a look at the other chapters if you're interested. And if you, right, there are many other resources as well for linear algebra. There are some books out there that take a more computational point of view, because computing with linear algebra is very important in practical application. So what are the algorithms that you would use to work with linear algebra computationally effectively on the computer? So there are many links to other areas of mathematics and many areas of applied mathematics. So if you're interested in this topic, there are many directions it can go in. Okay, for course mechanics, things are going to look pretty standard this week. We're going to have homework and following the success with having homework due on Thursday, this homework is going to be due on Thursday as well, and we're going to keep that for the rest of the semester, that homework will be due on Thursday. You have your Piazza post that is due on Wednesday, and you have your 1 or 2 responses that are due on Sunday. And so these are the what we always have. And we also, I encourage you to come to class on Tuesday on Zoom, and I encourage you to come to our problem session on Thursday morning. It's a good time to talk about linear algebra and think about these things. And I'm happy to talk about the homework problems if you're stuck, if you have some specific questions to ask about them. I know that this past week, our homework problem that involved looking at 2 norms on, or two inner products on the same vector space That one proved to be a bit difficult, and many of you struggled with that. So I will also post solutions to that one, but I'd like you all to think about it also a little bit more after I've given you your corrected work back.